in its extractions. Now, with that said, I said EPA says that the release of perfluorocarbon during the aluminum melting process results in global warming. Coal bauxite is extracted from the earth. The strip mining process removes all native vegetations in mining areas, resulting in the loss of habitats and food for local wildlife, as well as soil erosion. So you can see the mining process itself has a lot of devastating effects on both plants and animals, and even to the soil, because at the end of the day, once the topsoil is stripped just to get the metals, plants that are occupying the space have to be removed and destroyed. And in that case, don't forget that this plant forms the abode of other animals as well. So meaning once you are going for the minerals and have to remove the top layers, all these plants are going to be destroyed, and then the habitats of these are destroyed as well. So these are just some few of the hazards. Now the next element is iron production. This is also one of the important elements that are used to increase. Most buildings have them to give the building some strength and support. Now bridges use them, and because of their durability and their strength, one of the strongest metals within the earth crust. So it's also important to study them. Now, we said iron is also abundant element in the universe. It is found in many stars, including the sun. Iron is the fourth most abundant element in the earth crust, of which it constitutes about 5% of the weight of the earth, and it's believed to be the major component of the earth core. Iron is found distributed in the soil in low concentrations and found dissolved in groundwaters and the ocean. It is a limited extent in what's limited. Rarely found uncombined in metals and minerals are widely distributed. Now, it has to be extracted in the form of a pig iron from the various iron ores. Pig iron is the crudest and then the worst iron in the purest form of iron. The ore from which iron is extracted are a number of them. Now you can see that we have the magnite, which contain about 70 to 75% of ions. We have the hematite, the pyrite, and then the siderite. All these are ores from which ions can be extracted. So that's about iron. Now, when you also look at, you could see the number of.
Sir, hello, sir.
Yes, sir.
Sir, please, which page are we on, sir?
We are on. Oh, let me check for you. I just went to page 126. I'm going to start with extraction of ions by the use of blast furnace. Are you okay? Now, this is an old method that was actually employed by our old or our great grandparents in extracting iron from the soil. And the video I watched, you make spaces in them, put a lot of coals, that's firewood, under, and then they have to fan this after the metal. But make may have, and then the that they are paid, the claim finance, and then as and when it gets heated, it melts, and then they are able make another outlet where there's melted ions and other minerals as well, like gold, just collected and then cool down and then used for whatever ornaments they want to use. So, looking at the furnace, that diagram actually came to mind. So that's the structure of the machine made in extracting this metal, and one of it which has to be extracted, or else that the iron is being extracted from, is the hematite. Like I said, it has about 70 to 75% of the iron present in the form of iron 3 oxide, F2O3, Fe2O3. So we said in extracted, iron is extracted from iron ore in a huge container we call the blast furnace. The hematite contained iron 3 oxide. The oxygen must be released from.
Please, hello,
Yes.
hello.
Who is talking?
Please,
Ruben.
can I? Please, I want to know the page at UEB.
Oh, I said 126.
126.
Yes, that's. Are you okay?
Yes, please.
Unit 2, section 2.
Unit
Are you okay?
2. Unit 2, section 2.
Section 2.
Okay, so thank you.
Thank you, my brother. So we said that's the extraction of ions by the use of the blast furnace. I'm not reading much, but sometimes I have to read a little then explain, because I wanted us to cover the whole of it, and we can start with the 3. There's no time. So I said that the iron is extracted from iron ore. Can we go on? Iron ore in a huge container called the blast furnace. Iron ore.
And just put it nowadays.
Daniel, your mic is on. Daniel.
Yes, please.
Daniel Do, Mole.
Yes, please. Yes, sir.
Your mic is on.
Oh, sorry.
Thank you very much. I'm seeing that we have about only 16 joining this feed now. But when I asked you to write your name, I had almost 60 plus. And don't want the situation that you finish it and you have to come back and say each this thing and all of it. You can see how voluminous the whole section is. So please, let's continue. So we are saying that it's
Yes, please. You say we should write our name.
For the grouping, for that one, we'll do that when I'm done. I'll share it on the platform. I'm monitoring everything there.
Okay, sir. Thank you, sir.
Thank you. So you are saying that iron fuel has to be extracted under very high electricity or temperatures, about 1,900 degrees Celsius, just to be able to extract it. A number of substances as well are also used in addition to be able to extract the ore out of it. And one of these is coke. That's a carbon element that has to be used to burn the iron ore. That can even reduce it at around 12 to 30, 1,200 degrees Celsius to 13 degrees Celsius. It also has to do with the addition of liming or lime components, which may also bind the iron. So that's about the blast furnace. So please, we can look at it, and there are various changes we can see. We said at higher temperatures in the lower part of the furnace, we said we have the liquid iron on which the slag floats collect as the base. About once every 2 or 3 hours, the furnace is trapped. First, the slag is allowed to blow out, and then the glowing yellow pig iron is about 145 1000 degrees Celsius. That's quite high temperatures, just to be able to extract the iron. We said that the we also able to purify the last one is that it is similar to the industrial scale process. Depending on the ore used, the reaction conditions that the temperature is reaction produced is a mixture of iron ore. And then we have some added up to carbon dioxide to form carbon monoxide. The carbon monoxide is also used to burn the iron ore to separate the iron to produce another and other items as well. They're also saying that the iron is a very important use. I think earlier I mentioned that the framing of many large buildings, and then there's construction bridges, electric pylons, bicycle chains, cutting tools, right? Is very strong and attention. And then it's also used to reinforce concrete because it expands and contracts. Iron runs a lot the moment it comes in contact with acids or comes in contact with water. It binds with the oxygen component, and then that may result in rust. And you may see a total color change of the iron, and as a result, it also causes a lot of damages to buildings and bridges. And that's why it's important to study it. Therefore, people and engineers that work with ions look for ways and means to be able to prevent rust by undergoing alloying or galvanizing the metal. And sometimes, it is out of place we get the stainless steel that has the ability to resist corrosion. So that's about iron. So we say rust is of iron referring to the formation of rust, a mixture of iron ore on the surface of iron object or structure. This rust is formed from redox reaction between oxygen and the iron in an environment containing water. So like I said earlier, we may have the iron rusting when it comes in contact with moist, and therefore this moist, it contains a lot of water, and the oxygen content may react with the iron, and that may result in the coat that's normally formed, the flakes or a reddish flake. Some other books said reddish brown or brown flakes that describe the rust that has mounted on the surface of the iron. Now, in biology, we said that the rust formed on the surface of the metals can harbor some bacteria, tetanic, that can cause tetanus. So anytime you are cut by a rusted metal, we believe that some number of bacteria have been released into your blood, and therefore you need to go for treatment. Now we are just saying that When iron also rusts, it causes a number of damages. Bridges may collapse, buildings may break down, etc. There are various reactions that form rust, and that has also all been listed in the handout. So please kindly take note of that. So under the page before effect of rusting, you can see that there is a reaction of rust from where we have oxygen with the iron in the presence of water to form the rust. And then the rust formula is written boldly down there, F2O3HO2. And that's it. I've already spoken about the effects of the rust. We said one of it is rust can severely affect metals and make them weaker. Rust can cause the metal parts of cars to get stuck when they are exposed to slide over others. Now, it's a rust cars also car mufflers and other water bodies, outer bodies of the car can develop holes when they rust. That rust can also affect magnetic properties of metals, and then rust is also a good conductor of electricity. So that's about it. How do you prevent rust? One is, like I said, by employing alloy, where we have to mix the iron with other metals so that ions that have resistance to corrosion. So that's one way. So alloy is one of the methods that galvanization, the process of applying protective layers like zinc, metal over the iron. And and we said impose many types of that's about it.
Sir, please, it seems your network is not stable. Hello. Sir, it seems your network is not stable.
Is it okay now? Hello, can you hear me?
Yes,
Can you hear me?
Yes, please. Now we can hear you.
It's breaking, eh?
Please,
Is it okay now?
It's okay now. Yes, please.
Can you hear me?
Yes, please.
So we said effects of ion. Please, we are at page 120. Effect of ion mining on environment. Since this is also mostly like we saw in aluminium or an aluminium, we also have to destroy some plants and animals, destroying their habitats, destroying their food chains, and all that. So that also makes it a little bit distracting. You know, very huge machines that produce very loud sounds are all used, and that can also result both land and noise pollution, and even air some in the process. So it also has a number of destructive effects on the environment. So looking at it, one said that one of the effects of mining of iron is one on the environment is one loss of landscape due to mining processes. and transporting the iron ore, the coke itself, and the limestone. All these are substances that are used in mining the iron. So getting them under the earth, you have to destroy a number of, you have to destroy the landscape itself. Now we are saying that it also causes a lot of noise and air pollution, resulting in greenhouse effects and acidic rains. Loss of landscape, that's repetition of that. So that's about that. We also believe that there are certain elements that are also used to extract the elements, like where we may have carbon monoxide being generated from the process. And you know, carbon monoxide is toxic to the body, and same as sulfur dioxide, which is poisonous and can result in acidic rain, resulting in corrosion and all that. So that's about it. Now, the last element we are going to do is gold. And this one, I know most of us have an idea because of the devastating effect of the mining of gold through galamsey activities in our environment. It is one of the commodities that has very high price in the market now. So many people are going to it. And since it's one of the high valued metals or elements, it is widely sought after. We believe that there are a number of, or so many places have, California has a large number of these crystals, and it's all over. It can be found in water bodies, it can be found in igneous rocks and within the soil. In Australia, we also learned that a lot there, a lot about 200 pounds or 90 kg in mass is a lot. So besides, it can also be extracted under electrolysis. Now, this is also telling us that we have to go back and read more on our redox reaction. And that's about the electricity mining. Let me read a little on the mining of gold. Now, it said gold extracted by amalgamation or amalgamation contain a variety of impurities, including zinc, copper, silver, and iron. Now, we said the process we call the wool wheel process is an electrolytic process used in the preparation of gold. This process increases purity to about 99%. Wow, 99.99% of the electricity brings about the pure gold that we normally use. It is in this process, a casting of impure gold is lowered into electrolyte solution of hydrolytic acids and gold chloride. Under the influence of an electric current, the fasting functions as a positively charged electrode or anode. The anode dissolves and the impurities either pass into solution or report to the bottom of the electrofining tank as an insoluble slime. The gold migrates under the influence of electric fields with a negative charge cathode or the electric pure metallic state. So please how it can be extracted. So please can I read a little bit? Now we know gold is used in most ornaments like necklace and other ornamentals. The gold coins, now connectors of TV and then of laptops all use gold. And And that's about it. And that's about it. Today we are being told that Ghana's economy is being supported by gold. So, that I don't have connection here. So we'll use, please, we have to use the phone. My laptop is going down. So that's about the gold when it goes up. I'm also saying that gold is very important to us. Today we can experience and feel the effects of the galamsey activities due to mining of gold in our forests, in our water bodies, and heavy metals like mercury, which are non-biodegradable material, found themselves in fishes, in plants, and then in our water bodies. Most of these water bodies are consumed by us, and therefore having these elements in them results in giving birth to deformed babies and children. Last time watching the news, we saw how children given birth to in these areas, mining areas, have deformed bodies. Some suffering from brulee ulcer and so it has actually very bad. But because of it, we can't stop that to means that
The network is not good. The
mining.
network is not good.
I don't hear the last thing he said.
Chemistry, where the baby.
Been coming down. Hey, I still use UCC. Oh, that be that.
I said, let me call you back. I'm teaching. Okay, I said we have water pollution. Do you have it? Air and noise pollution. I'm joining. Yes, I'm here. I'm here. So let me use this. Okay. Hello. Okay,
Hello,
so
please, the network is not good at all.
hello.
The network is not good. At
Master,
all. You can't hear anything.
And
hello.
then if that's the case, let's use the WhatsApp call and see if that one will be stable. Or what do you
We
think?
use WhatsApp. We use. Hello. Can you hear you very well? Can
No, please. The
you hear
network
me?
is so it's breaking.
Can you hear me? Hello.
The network is breaking.
Is it still bad?
Yes.
Hello. I can hear you.
Yeah, I think it's
It's
better now.
okay.
It's okay now.
Yes, it's better now.
It's okay now. Okay, so then
Yes, it's
let's
better
move.
now.
So we're looking at the environmental effects of mining on the environment, and in that we said one of these is land degradation, water pollution, like I've mentioned earlier. We have air and noise pollution, acid mining drainage, and then toxic waste into our water bodies, and then mercury pollution. Like I told you, mercury is a heavy metal that doesn't break down no matter the years it takes. And once it finds itself in animals and plants, it's remained there permanently. And therefore, individuals that go to feed on these animals and plants may have the highly corrosive metals in their bodies as well, resulting in cancer and other dangerous diseases. So, good mining in the environment. And the next thing is the crude production. Now, today, one of the economic background of the world is crude. Though these big countries said they are moving to clean energy, they cannot do away with crude and petroleum production. So it's also very important, and therefore we need to study them. Now, we have to study this because this is actually what fuel us. You see, all the elements we mentioned earlier, the gold, the iron, and then the aluminum, all use high energies to generate. And most of these furnaces use crude, and therefore it's important we see how this is extracted and then how it is used. Now we are saying that this can be extracted using what we call as the fractional distillation. The fractional distillation where we may have the various components of the crude being extracted under different temperatures, but the crude itself needed very high temperatures because it's found at the bottom right on top of bitumen, what we use in making our roads black. So that's about it. So we're saying that you could see that the crude itself contains different gases and oils, and which is quite important to us, and therefore mining of this it's very important. There are various ways by which this can be mined, and I said one of the ways is by the fractional distillation due to the different densities of these elements and then having different boiling points. We may have them being extracted under different temperatures, and that's it. So that's under the fractional distillation. Now we said that there is also cracking and refining of these elements. And cracking is used a lot in petroleum refining. We said it is a process by which heavy hydrocarbons molecules are broken down into lighter molecules, employing heat and usually pressure. And sometimes catalysts have to be used. So that's one of the methods by which we may have some hydrocarbons being removed or break down. And actually, the crude itself is also hydrocarbons. Okay, so we said cracking is the most important process for commercial production of gasolines and diesel fuel. Cracking of petroleum yields light oils corresponding to gasolines. Now, middle range oils used in diesel fuel, residual heavy oils, a solid carbonaceous products as coke, which we have seen earlier. That's one of the elements that are used in mining, the ions and even aluminum. And we may also have some methane as coke. We may have some ethane and then ethylenes, which can normally be produced from ethanes. We also have some propanes and other elements, hydrocarbons as well. So we can get all these elements by cracking this petroleum product. And these are the beauty of chemistry. So there's a design under figure 4.4, which is showing the fluid catalytic cracking unit. So that's what is used in cracking some of the hydrocarbon. And then there's another method that they use, that's octane number. You can also read on that. Now we said, let's look at knocking. I think normally those of you who use cars may have more ideas about this. We said knocking is an internal combustion engine, sharp sound caused by prematured combustion of part of the compressed air fuel mixture in cylinders. In a properly functioning engine, the charge burns with a flame front processing smoothly from the point of ignition across the combustion chamber. At high combustion ratios, depending on the composition of the fuel used, some of the charges may spontaneously ignite ahead of the flame. Frequency pressure waves. Then these pressure waves force part of the engine to vibrate. So that's about the knocking process. And it said knocking can also cause overheating of the sparking plugs point. Can also cause erosion of combustion chambers. And then use of components of the crude oil. I already mentioned a number of them. And some of these components producing ethylene. So if you read page 139, you may see the uses. That's 4.7, the uses of major components of crude oil. Ethane is used to produce other hydrocarbons like ethylene. We have propane. It's also a hydrocarbon with 3 carbon atoms. It has 2 general market categories. It can be consumed and then some can also not be consumed. Propane has 4 major consumer uses. Please, we can't go through all this. It is there. Now we also have butane, which we can also get from the crude as well. And then all that. We can also see the natural gasolines that can also we can get from that. And that's it. That's it. Let me see. I want us to move to the next page first. Okay, so the next thing is on production. Let's look at this also briefly, and then we can carry from there. We said commercial glasses may be divided into soda lime silica glass and special glasses. Most of the tonnage produced being the former class. Such glasses are made from three main materials: sand, sand, some call it silica or silicon dioxide, the limestone, and then sodium carbonate. So these are the materials used in making glasses. Now, I say fused silica itself is an element glass, excellent glass, but as the melting point of sand is about 1,000 Celsius, as it is very achieve such height, it is its uses are restricted to those in which it is superior properties, chemical intense, inert, inertness, and an ability of withstand sudden changes of the temperature are so important that the cost is justified. So, since it's quite important for us, mostly you have to produce under high temperatures, which come with a very high cost. But because of the important nature and how it can easily sell, manufacturers will still produce this despite its high cost of production. So that's about the glass. We have seen the materials that are used in producing the temperature range at which they are produced, and then the need. Why glass is not a true solid? Glass is said to be amorphous and not true solid because it's the molecular it will take years, just a few.
Sorry, your network is getting bad again. Can you go back?
Oh, I just read 5.2. Are you okay? Can you hear me? Reasons why
Yes, sir.
glass
Yes,
is
explain
not.
why. Yes.
So we said glass is not a solid because it's not a true solid because we said it lacks the order of molecular structure. Solids. Are you okay? But that doesn't also qualify it as a liquid.
Sir, please, we can't hear anything.
You still can't hear me. We said glass lacks orderly molecular structure of all true solids. And I'm saying that with that said, that also doesn't qualify it as a liquid. Is it okay? Can you hear me now? Is it clear?
Yes, please.
Yes,
Yes,
it's okay
please.
now.
Thank you very much. So this is the reason why we can consider please, this is body written in the handouts. And I will say types of glasses and then their uses. There are a number of them, there are a number of glasses. Let me see if I can mention some few. Let me see. Who can I get? Rosemary, can you hear me? Tabuku, hello.
Yes, sir.
Rosemary, read on types of glasses and then their uses for me. Let me see if I can also hear you from there.
Um, sir, please, so let's
Page
go
one
back.
four, page 146.
Okay, just a minute.
Custom glasses is created using a specific cooling
Okay.
techniques to create.
Oh, so long.
Who is reading?
Charles said,
So you can read from your.
software glasses is created using a specific cooling techniques to create counteracting stresses, meaning that the glasses will shatter in the event of trauma rather than crack or break into shade to make it safe and less likely to cause injury. This makes it perfect for a variety of applications such as glass, doors, tables, exteriors, glass barriers, and shelves, etc.
And which side did you just finish reading?
That is
The float glass.
the tough
Glass.
Types
yes.
of glass.
Yes, types of glasses. That we
So
are
you
going
read
to
on the float glass.
they are painted
Yes,
glass.
float glass.
Yes.
That's what I read.
Can I
Then we
continue,
also
please?
have
Because I can't see what you just. So the float glass is made up of. It's made using a floating technique. Is that what you just read?
No, he read toughened.
Uniformness and superior
Toughened,
even appearance. Is that what you read?
No.
no,
Sami,
sir.
Yes,
which one did
boss.
Please,
you?
wait, one for
You
six.
read from tough glass. Tough glass.
Yes,
He read
Uh,
from tough glass.
and the toughened glass.
yes,
Yes, please.
Toughened.
yes,
Yes,
please.
please.
Oh,
That's
but
what
you didn't see
he
the
read.
float glass. You should have started with that one. I was watching that rather.
Okay,
So
the fruit glass
let me
is
begin
made.
with the float glass.
Which one, please?
Float glass, the first one. Do you have float glass there?
The
Okay.
first one,
hello.
Should I read?
floating techniques to create
Yes.
a uniform thickness and superior event appearance by
Yes.
floating glass
Hello.
on molten materials to create by floating materials on molten materials to create this level finish. Floating glass is perfectly created for large window panes, double glazing, and other applications with further processing. This type of glass is commonly used for multi-story office development, and it also gives
So
us
all that is telling us
give
that
a
this type
more
of glass is what we use for making our windows, isn't it? Because of its
yes, please.
clear and then lightweight. So I think that's it. And then we have the toughened glass. Some you can read on that. Chris, you can read on that one again. Read on the toughened glass.
Toughened glass is created using specific cooling techniques to create counteracting
Counteraction.
stresses. Yes, meaning that the glass will shatter in the event of trauma rather than
Sure.
crack or break into shards.
Mm-hmm.
To make it safe and less likely to cause injury, this makes it perfect for a variety of applications such as glass, doors, tables, exterior glasses, barriers, and
Mm-hmm.
shelves.
Okay. So that's about. Then we have the painted glass.
Yeah, we have
Painted
painted
glass.
glass.
We can't read on all this. The laminated glass. So please, you take your time and read on them for us. And now we want to see the environmental effects of open disposal of glasses. And you know what happens? Some of us that find ourselves in villages where finding slippers to wear is even difficult. Sometimes you're even wearing the slippers, and then these broken glasses can cut through to hurt you. But it has some also positives. I remember in the villages, most of us will go and fish using bottle. We just place them in the rivers, and then we go for them later in the evening. Then you may see filled with fishes. So we can also use them as traps. Some also use them for decoration, where they can break them and then reshape them into other forms for uses. So it has some great, both positive and negative effects. One of these negatives is sometimes form the breeding ground for for mosquitoes. Well, they call that one. So that's about. But they have important uses. That there are people that are using these glasses, and what happens is that because they don't have outlet to allow ventilation in and out, it makes the room more airtight. And mostly
diseases that are transported or are transferred by air, like tuberculosis, finding itself in such an area may affect all the inhabitants of that room. So in this area, I don't think it's advisable because of our high temperatures. But this is the order of the day. Then it means you have to employ the usage of but that's what has come to. Now let's look at also one of the commodities that politicians use in making a lot of noise, but high demand. The children property. So every man in Ghana here is trying to put up one block or the other, and the prices of cement is also shooting up too. They were told because of the dollar still in the market, but it's quite important. So what you see how cement is also produced and its impact. You are laughing, and its impact to the economy and its individuals. Who can read for us? Cement production, section 6.
Okay, so
Jerry.
Cement. Cement.
Yeah, Joseph, can you help us?
yes, please.
Cement is a fine grey
Fine,
powder
sir.
Hello?
that is mixed with water and other substances
Hello?
to make mortar
Hello,
or
Sami
sir.
is
concrete.
reading. Let's listen to him, please. Sami is reading. Let's listen to him.
Okay,
Okay.
okay. Cement is a fine grey powder that is mixed with water and other substances to make mortar or concrete. It is a key building material in both residential and commercial construction work. Cement, in general, is an adhesive substance of all kinds, but in a narrower sense, the binding material used in building and civil engineering construction. The cement of this kind is finely ground powders, powders that, when mixed with water, set to a hard mass. Setting and hardening results from hydration, which is a chemical combination of the cement powder compounds with water that yield submicrous crystals or a gel-like material with a high surface area. Because of their hydrating properties, construction cement, constructional cement, which will even set and harden underwater, is often called hydraulic
Hydraulic.
cement. Hydraulic cement. The most important of this is Portland cement.
Okay, so we are saying that cement is quite important because mostly that's what we use in construction, and it's because of its adhesive nature, it's able to dry very fast, and therefore also need high water. No matter the water you put inside, it will still dry up. And this is what is in building most of this. It can even harden in water. That's what they are saying. It can even harden in water. So that's the cement to talk about. Now let's see material that are for cement production. Who can help us? Another person should take it from there. Another
Okay.
person should take it. Yeah, Rose.
Let me from there. Minerals of natural origin, as well as industrial products, can be used for production of cement. Starting materials for this purpose are mineral compounds containing the main components of cement: lime,
Mm-hmm.
silica, aluminum, and iron
And
oxide.
mm-hmm.
Cement is pro- Cement is produced from raw materials such as limestone.
That can be used for the production of cement.
We are listening, Rose.
Okay,
So,
such
Please,
as
somebody's mic is on. Rose, hold on.
okay.
Mole, turn off your mic.
Okay, please.
You're not
Thank
saying
you. Yeah, Rose, let's continue.
okay.
So,
Okay. So
cement is produced from
limestone,
raw materials such as
limestone, iron, shale, clay, and sand. The lime component is
It
generally
is chalk. Take your time. Take your time. It's chalk. Chalk,
chalk,
shale,
clay, and
shale,
sand.
clay, and sand.
The lime component is generally represented by an amount of 76 to 80% lime.
Limestone is. Rose, we are listening.
Stone. Hello.
Rose, we are listening.
Okay. A minute to structure, which influences its color. The main component of clay is formed by hydrous aluminum
Silicate.
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 Silicates. Clays are divided into the following mineral groups. So how do you pronounce that word? Kaolin. Kaolin.
Cowling. Cowling. Cowling group.
Kaolin. Kaolin.
Cowlinate.
Kaolin group.
Dicite.
Kaulinite. Kaulinate.
Nitrate.
Dicates. Dicates.
Halosate.
Nitrates. Hylosates. Okay. And one what? One. So unless you pronounce that one.
Where is that one? I just move my eyes a little.
Yeah. It's more from the mention
Okay, so I can see multimorillonite.
of the silicate.
It's okay. So Mr. Chalk is a sedimentary rock which is formed.
By
Yes. Are you having challenges there? Let me take it from here. Somebody's mic is on. Is it Sole or what? What's the name? Is it Swale? Chalk is a sedimentary rock which is formed during the Cretaceous period in geological time. Blasting is not required for quarrying chalk, and crushing process can also be omitted. This kind of raw material considerably lowers the cement production cost. Calcium carbonate, which is widespread in nature of all geological formation, qualifies for the production of cement. So we have just seen the materials. The materials are listed here. Said one, lime, silica, aluminum, and then iron oxide. So these are the materials needed in that. And then in manufacturing of cement, have to undergo a number of processes and stages. The extraction and transport is one of them. That's the cement is hydraulic binder, which hardens when mixed with water. And main constraints are the limestone clay, which are extracted in large quarries with the use of explosives. The raw materials are loaded into damper and transported to factories for production. So that's the one. Then the next one is the crushing and milling. So these materials, after they have been mined, like any other stones or ore, have to be crushed under high temperatures. I don't need to read all that, you can see. And then after it has been crushed, this generates a lot of heat and therefore had to be cooled. So you have to also undergo some cooling processes. And that's it. Let me see what if I can add another thing there. Now there is also a clinker. Let's add that one. So the clinker leaves, and I'm told that this material is what actually makes the cement production very cost, because clinker is actually exported into the country at very under using so much dollars. So our cement producers, this is why they've been killing us and as high rising. Though the dollar is coming down, and they are still killing us. So the clinker lifts the cane to tumble onto a crate and is rapidly cooled with air fans. And then there's grinding. Clinker is grinded with gypsum and other mineral components to produce fine finished cement. And then there's storage too. Then the storage and packaging. And then after it has been packaged and stored, now it is dispatched to shops where they are kept. Alice Dangote and other local made cements has stood at it. So you can see the processes. We have the raw materials extracted, transportation, crushing, milling, and reheating, the kilning, cooling, grinding, storage, and then transportation. So these are the various processes that are normally employed when it comes to cement making. Please, the rest we can read them. We can read them, and it's go on and on and on. The effect of cement production, at least since it has to be mined using dynamite and other substances, it generates a lot of heat and then noise pollution, including air pollution as well. So don't forget. Not also forget that since they have to be mined, like we saw in the other element as well, there are a lot of distraction to plants and animals as well. And I think we can leave it here. Let's look at biotechnology under unit 3. To be by the car. I saw them sitting behind them. So ask the lady there. I say, oh, guys, sorry. Now, biotechnology. This. Let me make it quite simple. This process is employed in our homes. I know Rosemary would like banku a lot. Rosemary, isn't it? Rosemary, are you there?
I'm here. You said
Good.
I would like to come.
I know you like banku a lot.
So why did you say that?
Yes, I can just see from your voice. It says that your voice is saying that you like banku a lot. And now you know one of the methods by which we employ the usage of biotechnology. You know, after you are going to mill the corn, you leave it for some time to undergo some level of fermentation. And you see, this is what brings about the taste. It gives you taste. You get it? Because we may have the starch being broke down into simple sugars like disaccharides, which have some amount of taste in them. And these are being done by microbes. Microbes like fungi. Are you following?
Yes, sir.
Technology, we are seeing how certain living organisms can be employed in the production of substances or products. For the betterment of man. So, in a problem where beverages are made, we see the fermentation of barley. The millets or the grains that are being used, and then cause them to undergo oxidation processes. And this may cause the change. And this is what is used in producing most of the alcohols we have. And that is the impact or the real impact of biotechnology being.
Can I say
Yes.
something? Recently a woman was doing something in the house and I asked her and she said she is doing asana.
Good.
So
Good.
You have to leave the maize for it to ferment as if it's germinating.
Good.
Uh,
So see, and that's she's just applying science there. Do you get it? She just applying
so
science. So the grain have to undergo fermentation before she has to go and mill it and use it for her asana or whatever she's trying to make. So that's biotechnology being employed. The making of cheese, yogurt, and all these food substances are employed. But today, the study of science is taking biotechnology to a different level altogether. You get it? Today, the genetic engineering be employed, the study of genes and the DNA sequences. We may have certain manipulations of the genes or the DNAs to produce other forms of DNAs, which the scientists are using in large production of certain components they want to make. Now today, insulin, which is produced by your pancreas, is being manufactured artificially to regulate your body blood sugar. You get it? So this is what biotechnology is doing now. Now farmers want to produce more. They want to produce more by inducing the plant genetically to produce more produce than the original plant or the natural plant can do. Today, fruits are being produced at higher sizes due to induction or manipulation of certain genes of these crops to produce the breeds that the farmer needs. And all this is employing, or they are employing biotechnology in these processes. Do you get it? In producing these foods. Today, farmers can induce their flocks or their animals to overproduce. Some inject them with other elements apart from inducing them genetically to produce very big, huge animals from the same local made animal. So that's about the technology employing don't forget the genetically modified organisms and crops. You see, today we can see certain crops that cannot even withstand very harsh weather conditions and they can wither easily. Scientists have caused these organisms to be able to survive in these harsh conditions, and they're able to produce more out of out of it. So, with the employment of biotechnology, scientists are producing more, farmers are producing more. Um, we may have flocks of these farmers also producing more. So that's how important biotechnology is and has come to stay. Please, I've explained this without even reading. I find that so, like I said, various branches and how biotechnology is applied in our lives. It is used in
Please,
the medical
please,
field. Yes.
please, the network is not all that good here. I don't know.
Oh, brother. So, before we read Kenya,
Mati, but we have understood you, sir. But it seems at times it will break. Thank you, sir.
okay, welcome. So, what I'm saying is that I'm trying to read on section 3 and 3. Okay. So, you are saying that there are branches and applications of biotechnology, and one under the medical field. Today, there are a lot of antibiotics that are being produced now through induction of science, biotechnology. Treatments are being given to people. Do you get it? Aha. Yes.
I said yes, sir. You said, do we get it? And I said yes, sir.
Okay, so I said, so let me read a little under the medical biotechnology. Now I said this deals with the diagnosis of various diseases, large-scale production of various drugs, and even hormones, such as insulin, like I mentioned earlier, and then interferon, vaccines for chicken pox, rabies, and polio are all being made, and these are used in treating various diseases and conditions that man is suffering. Those days, we have to try a lot. Even currently, most of us have to depend on some concussions here and there. Recently, I realized that I'm having these pains under my lower abdomen. When you're having such pains, a lot of things in your head. Is it kidney failure? Is it pancreatic or problem with your colon? So as a scientist, I just sort of went to the drugstore, spoke to the guy, and then describing, the guy said, okay, then it could be ulcer. He suggested a number of things. It could be ulcer, or it could be an infection. So you see, I took the second one because I don't remember having stomach ache anywhere. I eat my food all right. I eat anytime and I'm okay. So I just went for an antibiotic. Within 3 days, all the pain is vanished. So and that's it. So today, this manufacturing of these things are helping. People are having challenges with their insulin content, and therefore they are having high blood sugar content within their blood, and they can not convert them into glycogens. So once this can be manufactured, if he buys and injects into the blood within the shortest possible time, you see the blood will be normalized, and therefore the person will be having it. And this is what science has brought. So this shows how biotechnology is being employed in the medical field. Now in the industries like the production of some of the vaccines we even spoke about earlier, biotechnology is being employed there. What again can I even? The alcohol productions and all that, we may have these microbes being used and then in the environment. People don't know that sometimes when there is oil spillage in the sea due to this extraction or mining of these oils, the spillage. And what scientists do is that, you see, since it's less denser than water, it suspends and covers fishes that tries to garble some small amount of air. And you see, once it traps or it's covered the surface of the water like that, oxygen can't dissolve. So if these fishes find themselves in low oxygen water bodies covered with these oils, the fishes in there are going to suffocate and die. Plants will be entangled with these oils and then they cannot be able to undergo photosynthesis and they will die. And that can result in number of negative conditions to the animals dwellers within the environment there. So sometimes scientists can release certain microbes like bacteria that can consume methane or that can consume these hydrocarbons. Do you get it? Just to make the water clean. To make the water clean. So this is how they are employed. And don't forget that most of these microbes are living. That's why you leave your food down without protecting it. You come back the next day, they have been invaded by some rhizopus or yeast, and your food is going bad and you don't know. I just left this food here, and when did it become bad like that? You get it, and they are all over. So most of them are, and to be frank, they help a lot. You see, when you leave your food and the food is organic, and then you don't protect it, the organisms may see it to be either food for themselves or maybe a nuisance that has to be removed. And you see, when they invade, the food start producing very high heat and high scent. But within some days and over, the food dries and sometimes it will even break down entirely. And what have they done? They have recycled whatever nutrient you have in the food, and it has gone back into the environment, making the environment more healthy. These nutrients will be tapped by plants to grow. And then once they grow and they are producing the food, you, the animal, you chance on it and you start using them. So they are very important as well. So you could see they are also employed in agriculture, like I've spoken earlier, using to produce genetically modified crops and animals, increasing yields for and all that. I think the applications are many, which we can all read more on that. And then the branches, still on the branches, oh, Charlie. Let me see what we can have. So the next thing, section 4, general classes of biotechnology. It is classified into 4. We have the blue biotechnology, we have the red, we have the white, and then the green. But please come to page 183. 183. Please, are you with me? Page 183. General classes of biotechnology. Dominic, Abubakar, Mariam, Hafsa.
Yes, we are there, sir.
Can you hear me?
Yes, sir, I can hear you.
Page 183.
Yes, sir, we are here.
Yes.
Can you look at the various classes there and tell me what you see? Under the blue biotechnology, the picture, what do you see? A. Machimo. Someone tie. Some machimo.
Sir, we are there.
Sir, we are there.
Calculation.
Patrick.
Yeah, we are there. Just that the model we are using, the pages are different from here.
There is a
Eh.
No. There is a fish.
I see a blue technology, red biotechnology.
One. Yeah, so what do you see? What the picture? Let's look at the blue. What do you see?
Then a fish that is outside the
A
pond.
fish. Okay, so somebody said a pond.
Yeah.
Okay, that's what you can say. That's excellent. And then in the B, the red, what do you see?
A patient
That's
standing by a drip machine, a drip stand. Sorry.
I can. Is that?
Yeah, we can in the picture we can identify a patient, a string, and a medicine in the bottle.
Oh, okay, so a strange. Okay, I can see. Okay, that's good. And then let's see, what do you see?
Industries.
Industries. You see industries.
And a smoke coming from the industry.
Smoke coming out of the industry.
And then what again do you see there?
Mushroom.
You see, good. And then I can see another plant too. There's a plant too. Okay. And then I can see something like, what can I see? Okay,
I
so
can
I
see
can see a bacteria.
like a raw material feeding the industry.
That's it. Thank you very much. And then what are the green technology?
Apple with
A fruit that's set into two equal parts.
So a fruit divided into two equal, and then you could see that it's being injected with something.
Injected with, yes.
So like a bad fruit going, and then once it's been injected, it still looks fresh, right?
Yes.
Okay, so let's go back and then see what we have there. Now with the blue technology, we have to do with aquatic environment and animals and plants that can be found in such an area, and how important these organisms are to our ecosystem. So we know we have different water bodies. We have the marine, we have the freshwater bodies, and even we also have what we call the estuaries. And in all these water bodies, there are various animals in there that try to maintain and make sure that we have a healthy environment. You get it? If you go into any water bodies, mostly the plant species you may see there are algae. We have different type of algae, the green algae, we have the red, we have the brown, and all these organisms undergo photosynthesis, providing food for the fishes in there. You get it? Don't forget that there are gases that may also be needed in the process of photosynthesis which these plants are absorbing. If the gases like carbon dioxide is not absorbed by the plant, it's going to make the water more acidic and therefore that can result in the death of these animals. So we see where these organisms make use of these gases like carbon. Believe that algae and bacteria also help in maintaining the shape of the environment. If you take bacteria as an example, we believe that they help in recycling. Most of these fishes and plants may die. And when they die, their end product shouldn't remain in the water. They have to undergo some recycling. So these are in these water bodies are helping shape our environment. And then the study of these things also help other scientists to avoid them in, in shaping our environment. Look at jellyfishes, where scientists can employ and study how they emit certain neurons. Do you get it? I think I read earlier also on where pharmaceutical industries use some of these materials as enzymes to replace certain conditions within our environment. You know, we can have certain organisms like the bacteria that can live even in the hottest part of the sea. You get it? And once these were studied, it also helps scientists to be able to develop conditions and machines that can even help develop this strong machine to resist these high temperatures, to be able to pick some of these bacteria for study. So behavior of these animals in the water bodies, the microbes, the plants, all shape the knowledge of science within our bodies environment. So this is about the blue biotechnology, about the blue biotechnology. And don't also forget that most of the things we have in the water bodies, like the algae, are used widely. Some even feed on the brown algae as food. I'm told that when you go to China, it's a delicacy there. But here we don't eat. It's all about contumely and nyadra and other food substances. Now it can also be used in drug making and even to produce fuel. So this is how important some of these materials in the water bodies help both the animals and plants as well. So we said that in the marine, there's a diagram we can study. There's a diagram there down there. We said it is employed in biotech, where we can see biodiversity discovery. Most of us are learning and studying the marine. We learn that it has a number of things man have to study, and there are a number of microbes. You can see the number of gases also being generated, methane and sulfuric hydrogen sulfide, that are all being trapped and harvested in such environments for the usage of man. Like I told you, most of these products that are being generated out of the sea are used as food, they can be used as fuel, they can be used in the pharmaceutical industries, and a number of places. So that's about it. We can move on to the is it the red? Let's move on to the next application. The red. Oh no, that's the green. So that's the green. Now with the green biotechnology, mainly with genetic modification of plants to make them more drought resistant or to strengthen certain characteristics, traits to receive a better yield or to make them resistant to viral diseases. So today, biotechnology is being employed in farming, mainly to make sure that plants are able to produce more. Like I mentioned earlier, in genetically modified food, we may have some plants being induced genetically so that they may be able to produce more yields. Today, you buy a fruit, you put it down, and the fruit is not rotten, and then you ask the question, what is happening? In this area, most of the food they sell around, like the yam and the chips. Is it chips? Yes, chips, and then the plantain chips. I'm told they to preserve them, they even have to use rubber, plastics. And please, that's not biotechnology being employed there. I hope you get it. That one is they are killing us. They are killing us, and that's not biotechnology being employed. So we have scientifically, we may have some genes of certain plants being induced to produce more, which is being employed now. It's being employed in agriculture, it's being employed in horticulture, in animal breeding processes, so that these animals, one, may be able to be disease resistant and also produce more yields. So that's under the green. Under the green. And there are a number of processes that are normally employed. Sometimes some may undergo what we call as the tissue culture, where they may harvest certain cells or tissue from one particular plant and then embedded it into another plant, or its extract is being taken and then put it in another plant so that the plant may produce that the varieties of that plant. So that's about being employed in agric. Now there are different fertilizers that are being employed, different biofuels and energies that are being produced from biotechnologies, and that's it about the green technology. And then we also have sorry, I don't have water here, I'm coughing too much. And then with the white biotechnology, we said this deals with the use of biotechnological process to produce food or drink. I think this that I have hammered it so much. Now, such as bread making, beverages, or in alcoholic beverages, making of cheese, yogurt, and all that. We may have biotechnology being employed. So mostly in bread making, the fungi yeast is what is normally used. And since this organism can still survive in anaerobic condition, it's able to respire and produce a lot of carbon dioxide, which we believe deflates the bread and therefore, inflates the bread, causing it to increase in size for the benefit of the seller. It also helps to increase the fermentation.
Yeah, please, are we done?
Yeah.
Hello?
Hello.
I can't hear anything. I'm
Hello.
asking. What have you?
You were asking question.
No, please. I'll just try to find out if we are still on course.
Yes, I'm here. It means you went off, eh?
Yes, please.
Where biotechnology is being employed in the production of food. Are you okay?
Which way are we, please?
Are you okay? Is that?
Which way are we, please? We are doing biotechnology.
We are looking at white.
Are we still at green biotechnology? The line is still breaking.
Page 195.
Page 195.
And you are making me scream. Oh.
Yes, and biotechnology 4.3. That's what we are doing.
Yes. Are you okay?
No, please. The line is not clear.
In some of the models, the page is 185.
The line is not clear.
Yes.
Which line is not
But
clear?
in some of the models.
Is it blue technology, right?
Who is talking? Who is asking the question so that I can help him? Who is that?
Yeah, he's asking of the page, and I said if you're using the model, the book itself is 175, page 175, sir.
Your book is 175, eh?
Yes, please.
Mine is 195.
And
But
then
we are 4.3.
4.3. 4.3.
The pages are different. The pages are 4.3. Yes.
Oh, okay.
So
They tell him to go to white biotechnology.
Okay.
So go down.
I'm there.
And with all that is stated there, telling us that we use biotechnology in the production of food. And they have given examples in bread making. And I was explaining that we have yeast that is used in making bread, which is a microbe, but it's being used to produce food for us to depend on. And I said that apart from the bread, the production of cheese, alcoholic beverages, even kenke, all are employed in the production of this biotechnology. And then we have the gray biotechnology. I can't see the red, the gray. So that this refers to the environmental applications and which is focused on the maintenance of biodiversity and removal of pollutants, contaminants, using microorganisms and plants to isolate and dispose of different substances such as heavy metals and hydrocarbons. Earlier, I gave examples of how microbes are used in removing oil spillage on water bodies. Hello, are you following?
We are there.
Yes.
Yes. So we see that biotechnology has come to stay. So all the scientists do is that they either create or cause the growth of those bacteria. When there is spillage, they harvest and then spray them onto the hydrocarbons. And then with time, you will see that they eat all the oil from the sea or from the water bodies on which the spillage has taken place. So this is how these microbes are helping to clean our environment. I also said that when you leave your environment of filth, mainly if it's organic, we may have most of these organisms trying to remove this and other heavy metals from our environment, making it polluted.
Hello, sir. Network is off.
I guess the network is very bad.
This online issues come to disturb us. Oh. The network is very bad. Network is very bad. It's not good again. The network both MTN and Voda. They're very bad. These days,
No,
they're
I think it's his laptop that's off. You know, he's complaining about his power being low.
I
I
he
think
was
his
saying
laptop
the
is off.
laptop is running down, so he will be using his phone.
Please, Master was saying that he has created
You have joined back.
Hello, I'm back. Hello. Sorry,
Yes,
I'm back.
Hello.
My phone was off. I'm back. Are you okay?
Yes,
Yes,
sir.
sir.
Yes.
I'm back. So I was saying that I just made an observation. I realized that one of these pure water companies is using a plastic that is biodegradable. It is quite soft, more flexible, okay, and it can break. You know, plastics are non-biodegradable materials, and you could see the devastating effect of these plastics in our environment, even in fishes and then even on the environment itself. In soils, doesn't cause plants to grow and reproduce well. So we believe that once they are being induced, they can break down very well so that we can also have our soil to produce as much as we can. Even if it's even find itself in the body of other animals like fishes, this material can break down. And to be frank, currently the plastics are killing most of these animals. So biotechnology is being employed here to produce biodegradable plastics that are quite important to man. So that's it. So please, you read a little on that. And then we have the red biodegradable biotechnology. He said the process of biotechnology that works in the medical field to improve health using organisms is considered to be the red. So I've already explained this. So where we may have these microorganisms being employed or this technology being employed in treatment and in making of vaccines and drugs to treat humans and of their diseases is found to be grouped under the red biotechnology. So I think that's okay. With the applications of the red biotechnology, we said one is genetic testing. Um, we said there are numerous diseases in the world, and some of these is some are diagnosed with common drugs, whereas some are very serious and can be fatal. In this way, genetic testing can identify genes, cure them with relevant drugs treatment. So that's it. So with today, once genes can be studied or DNA sequence can be studied to find out if the person is having certain conditions, that is quite fatal to treat. And then once the gene that is causing the condition is identified, the treatment can be done. That's the level which science can go. So gene therapy, replacement, it can be by deletion or can be by substitution uh, to treat certain conditions. So look at it. This is employed in treating diseases such as cystic fibrosis, heart diseases, even including AIDS. So that's it. Now we have the pharmacogenomic. Now, often treat patients of the same trait with similar medications. Some are cured and some are not affected. This means that the person's genetic inheritance causes their body to respond to drugs and medication. So, under the pharmacogenomics is a method of studying the role of genomes, that the general genes population in your body in drug response. So that's it. So this can also help the doctors to also see how best you can respond to certain diseases and certain drugs and what not the others, and help in treatment of the condition. During this COVID period, we were told some people are asymptomatic. They have the conditions, but they don't show signs of it. Then they are living their life all right. So people like that can be studied to see how their genes are able to respond to changes and why others are having their conditions crash down. And therefore, a harvest of a gene from such a person can be multiplied to help others survive as well. So that's what I'm thinking. But I don't think science has reached there yet. I think we've done well. Now, effect of biotechnology, at least you could see that most of these things are all positives, being employed in the medical field, in our environments, and then even in our food production. You get it. So it's quite important. It's important. So it has great positive impact, and as causing the yields of foods, and it has some negative impact in agric. Um, it's a biotechnology indeed has done a lot of good for the world, but it also has some disadvantages, and there are some concerns about its potential negative impact. In agriculture, some concerns genetically modified crops can transfer genetic materials into natural unmodified plants. For instance, in herbicides, resistant plants may transfer some of its traits to a wood, which could result in an herbicide-resistant wheat. Another concerns about agricultural biotechnology centers around the uncertainty of genetically modified crops' long-term variability. So that's it. That's it about the impact of biotechnology. Now, I can also see something on nature. It said that the long-term consequences of genetic alteration of various organisms, from bacteria in the pharmaceutical industry to the animals to biological research to the plants in agriculture, are still unknown. So there are still gray areas in these areas for people to study, especially how these changes takes place. So the genetically modified organisms may also escape into the wild, especially transgenic the balance of the ecosystem, like we saw in the case of for instance, the pandemic. The pandemic we just experienced. So how do you call the conditions? COVID. We're told that the condition was actually manufactured in the lab, and one outside the lab, we were not in China, neither were we in America, but we have the effect of the condition here. People had to be quarantined, and some areas have to be locked down and all that, affecting the balance of the ecosystem. So that's it. Now we said it's socioeconomic risks. It also caused a lot of changes and affect. But though other countries were cashing out because one of the conditions were released outside there, they were having monies, they were having antiviral drugs that they could sell to make their money. So they were cashing out hard on other countries such as Ghana, where we don't have the means to protect ourselves. So it also has a lot of health hazards and all that. So I think we have done justice to this. Please, if you have any question, you can ask. Let me see this. And then I think we have some few time to do the groupings. Are you there?
Yes, sir.
Hello.
Yes, we
Hello.
We
are
have
there.
few times to do the groupings.
Okay.
The book is in, I think, how many units? Is it 6 units?
It's 4.
Please,
It's 4
ours
units.
is 4.
It's 4 units.
Yes, please, 4 units.
Yes, sir.
And we are bad.
Next week is practical.
No.
So the house for practical.
You people, are you going to do practicals online?
Next week.
You're laughing. You're laughing.
So how do you go for the practicals?
You don't know. When we get it, we shall cross. What I'm told is that even the section 3, the unit 3 I just taught had to be part of the groups. It's supposed to be units 3 and 4.
That's for the presentation.
It's supposed to be unit 4. It's supposed to be units 3 and 4. Yes. And then each section, each unit has 6 sections. Are you listening?
Yes, sir.
So we are about 60. 1 to 30. 1 to 30 will take what we just did. 3. We are dividing the 30 into 6 groups. So maybe 5 group 8, isn't it?
5 groups. Yes, please.
5 group 8. 1 to 5. Take 3 unit 3 section 1. 6 to 10 will take unit 3 section 2. And then 11 to 15 will take section 3, right?
Okay.
And then 16 to 20 will take section 4. And then 21 to 25 will take section 5. And then 23 to 30 will take
section.
That goes. So we are, isn't it?
Yeah, please,
You said 25 to 30 take what? We didn't get that one clear.
They'll take you section 6. Unit 3, section 6.
Unit 3, section 6. Are you okay?
Okay.
Yes, sir.
So 31 to 35 will take unit 4, section 1. So 31 to 35. 31 to 35 will take unit 4, section 1.
sir.
And then 36 to 40.
Sir, please, unit 3 ends on section 5, not section 6. Unit 3 ends on section 5. We don't have section 6 under unit 3.
Are you sure?
Yes, sir.
My phone is.
Section 6 in unit 3, sir. Yes, sir.
I'm coming. You hold on.
So the 25 to 30 can
Hold
get.
on for me.
Okay.
You said unit 3 ends where?
Section 5.
It's true. So okay, so let's continue. So then it means unit
Those days
is it
section
25 to
25
30?
30.
25 to
or
30.
section.
25 to 30 will now start. Will start unit. Where is it?
Unit 4, section 1.
Unit 4, section 1. Okay, thank you very much.
You're welcome.
And then the 31 to 35 will do section 2 of unit 4. Is it okay?
Yes, sir.
And then 36 to 40 will do section 3.
Or section.
Is it clear?
Yes, sir.
Hey, you do number ben, me feel. Number ben you do. Where are we?
Then 41 to 45.
We'll do section 4. Then we'll do section 4. Is it okay?
Yes, sir.
And then 46 to 50. We'll do section 5. Is it clear? And then the section 6. Please, section 6, the rest of you are all there. So share the topics among yourselves. And please, share the topics among yourselves and let's deliver. You can make it 5 by 5. Okay? So please, Rose.
Sir.
Rosemary, you do that for me, eh?
Okay.
Do the grouping and then put it on the platform for me, okay?
All right, sir.
With the names. Oh, the names. Thank you so much.
Do that.
You said?
Hello.
I said do the grouping. But if you have challenges, any person who can help should do that with us. Okay, so thank you so much. And enjoy your day, eh?
Thank you, sir.
If
sir,
I
hello.
I'll put it on the
When are we doing it?
Hello. And please, we are only 19. We are over 50.
So please, with the presentation, how is it going to be done and when is it going to be done?
I'm told after the break. I think after next week, right? I don't have the timetable with me, but I'll check and communicate. I'll put it on the platform. Are you okay?
Hello, sir.
Yes.
Sir, please, you ask the practical.
The practical. I'm told it next week. Listen, I'm told it next week. Are you listening?
Yes, sir.
I'm told it's next week. Let next week come, then we'll know what to do. I hope you're okay.
Okay, sir.
Thank you, Charlie. Charlie, have a nice day and enjoy your day, please.
Okay, sir. Thank you. We are all here. Sister Roseman, please, let's see the names. Let's see.
So
if we get time that.
What I'll do is
Sister Roseman, please write the first 5 in their names. Then you say group 1. Then the next 6 to whatever group 2. Then repost it on the platform so that we all know our groups. Then we can join and call individual.
I want the list.